Hello viewers, welcome to Biodrunks. Let's learn some aspects of biotechnology. For your reference, I'll be providing notes, PDF link in the description. This video is also available in Hindi and Telugu. For more videos and continuous learning, please like, share and subscribe. Let's start! In the previous video, we have done all about type 1 restriction enzymes. We have learned about them. So now we are going to do type 2 restriction enzymes. So let's first know what is this type 2 restriction enzyme. So these type 2 restriction enzymes, they are very diverse in nature because of their amino acid sequence, sites, domain recognizations or domain organizations, and their subunit composition or the cofactor, their cofactors, okay, and the most important is the mode of action. This is how diverse is type 2 enzyme, and hence they are characterized into various subtypes. Okay, so what are these type 2? They are mostly dimers of only one type of subunit. Okay, so they have two subunits, which is R and R for restriction and M for modification. Okay, now these enzymes are unifunctional, means they function separate they have separate endonuclease and methyltransferase function. They have separate, okay, and they have two subunits as we just saw. Now, the recognition site of the type 2 restriction enzymes are palindromic and there are 4 to 8 nucleotides in length. So, what happens is methylation or modification, they occur within the restriction site. Okay, they occur within the restriction site. But when you talk about restriction or cleavage, they occur within or near to the restriction site. Okay, so these occur near to the restriction site or immediate vicinity. Now, they do not require ATP or adenomethyleucine, but they take M-magnesium as their cofactor. They usually use magnesium as their cofactor. For modification, the adenomethyleucine is used, but for cleavage, only magnesium ions are used. So this is all about the type 2. Now let's go and learn about the subtypes of type 2 restriction enzyme. So let's talk about the first subtype, that is type 2E. So now this type 2E, they cleave the DNA following the interaction with two copies of the recognition sequence. They have two copies of recognition sequence. So how does they interact? One being the target for the cleavage, and the other is an allostatic effector. Allostatic effector means, for example, okay, so here I need a substrate of this kind, okay, but I'm having a substrate of this kind. I'm not having this, I'm having this, okay. Now what happens is, this electrostatic effector, it would join somewhere here, and this changes the site, and then the substrate can easily bind here. That means what? It's binding at some place and the effect can be seen at some other place. Okay, this is called as electrostatic effector, means the one copy, okay, there are two copies of recognition sequence. One is serving as an electrostatic effector, and whereas other is for the cleavage. Okay, this was about type 2. Now, type 2S. So, what is this type 2S? So, it is a monomeric restriction endonuclease that keeps DNA at a defined distance. So it is cleaving the DNA at a proper defined distance now. Okay. And they are non-palindromic recognition sequences. Non-palindromic recognition sequences, and that is asymmetric. Okay. So one example of this is 4. Okay. Let's go to the next one. That is type 2M. So as the name M means methylation. So it recognizes methylated DNA, the DNA which is methylated. Okay. And for this example is DPN. Great, easy. Now, type 2B. So, what does type 2B do? Type 2B are multimers. Okay, and they contain more than one subunit. Type 2B, they contain more than one subunit and they cleave DNA at both sides of the recognition sequence. They require both adenosine methionine and magnesium as the cofactor. Okay, so let me write it here, cofactor. And the example is 2. Okay, let's go to the next, which is type 2F. What is this type 2F? So type 2F interacts with 2 copies of the recognition sequence. It also interacts with 2 copies, but the difference here is, the difference with type 2E is it cuts at the same time, it cleaves at the same time. Okay, so what is happening in type 2 is, first it is activating at one side and then it is cutting. So that's how it is working. But in type 2F, it cuts at the same time in both. Okay, so till here, hope it's very clear. Let's go to type 2G. So type 2G cofactor is adenosine methionine. The cofactor of type 2G is adenosine methionine. It has a single subunit. Okay, so this has both restriction and modification activity. Okay, so the example of type 2G is E. coli 571. Now let's learn about the type 2T, which is the last one. See, type 2T is composed of 2 different subunits. Okay, so one is used to recognize palindromic sequence. Okay, while the other recognizes asymmetric sequences. One recognizes the palindromic sequence and the other recognizes the asymmetric sequences. Okay, so this is what the function of type 2T. Now let's learn about its example, that is BP4101. This is one example of type 2T. Till here, we have learned all the subtypes. Now, on the basis of the previous video, now we have a proper knowledge about type 1 and type 2 restriction enzymes. So, what's the difference between both? See, when I talk about type 1, it is bifunctional. Means it has both endonuclease and methylase activity at the same time. Whereas type 2 is unifunctional. Okay, so it has separate methylation and endonuclease activity. Now, this is having 3 subunits. So what are these subunits? The subunits are R for restriction, M for modification, S for specificity. But it has 2 subunits. And what are these subunits? Restriction and modification. Now, type 1 restriction enzymes, they also they cut at least 1000 base pairs away. And type 2 restriction enzymes, they cut near to the recognition sequence. Okay, near or at the recognition sequence. So type 1 is not having subtypes, type 2 is having a lot of subtypes. Okay, here they require adenosine methionine and ATP as cofactor. Okay, but when you talk about the cofactor, here they need magnesium. Okay, I think it's really very easy. We have almost learned about the differences. In the next video, we will be continuing this with the more reach, that is, we are going to do type 3 and type 4, and we are going to learn more about them, and then we will find out the differences between all the three. This was all about today's video. Hope you liked it. For more such interesting video, please like, share and subscribe to Biodrunk. Let's meet in the next video. Bye-bye.